In this series of videos, we're going to look at scientific notation at National 5, and in particular in this video, expressing large numbers in scientific notation. By large number, I'm basically meaning anything that's over 10. Now, what's the point? Well, we use scientific notation to make very large or very small numbers easier to comprehend. So if we're starting to look at things that are in the millions, billions, trillions, so on, or even at the microscopic scale at the other end of the spectrum, we're starting to look at ways in which we can interpret what those numbers actually mean. So we're just going to launch straight into this. We're going to look at how to convert to scientific notation. And there's 4 steps to it. The first step, we're going to move a decimal point to create a value which lies between 1 and 10. As soon as we get to 10, obviously, we have to go back to putting a 1.0 again. Then we're going to count the number of places the decimal point has been moved. Then write times 10 to the power of whatever the number of the places the decimal point has moved. And then we'll remove any excess zeros. Okay, now this looks more complicated than it is. So rather than just having to write out the notes, I'm going to show you exactly what I mean by this. So our first example, we've got 3,500. And we're told to move the decimal point to create a value which lies between 1 and 9.99. Well, our decimal point normally in this is here at the end. We don't tend to write a decimal point at the end of a whole number, but it is still there. So I want to move the decimal point to create a number between 1 and 10. Now, the easiest way to do that is to think, well, 3.5 is definitely between 1 and 10. So 3.500 times 10 to the power of, so we're launching at step 3 here, count the number of places the decimal point is moved, and we're going to put times 10 to the power of whatever that number might be. Okay, so we can see it's moved from here to here. That's moved 1, 2, 3 places, so this is times 10 to the power of 3. And our final step said just to remove any excess zeros. Now, normally when we're writing a decimal, we don't put any extra zeros at the end if they're not needed. So this is just 3.5, these zeros disappear, times 10 to the power of 3. Okay. Our next example then, we've got this big number here. Now, 1, 2, 3, this is 7,120,000,000. And you can see that I had to actually count in threes to try and work out what that number was going to be. So you can see straight away that it's pointless having a number this big when we try to make sense of what it's actually representing. It does make more sense to have it in something like scientific notation. It makes it easier for us to understand straight away what we're looking at. So again, our decimal point would normally lie at the end. And we have to think, well, I have to create a number that's between 1 and 10. And again, this would fall between the 7 and the 1. So 7.12 with 7 zeros. This is times 10 to the power of. I'll just move my camera a little bit. This is times 10 to the power of, well, it's moved 3, 6, 9 places. So it's times 10 to the power of 9. And then we can get rid of any excess zeros that we don't need. So all of these 7 zeros can disappear. 7.12 times 10 to the power of 9. Okay, and our final example. Well, what happens if we've already got a decimal written in the number? Well, the same thing happens. I want to make this a number that's between 1 and 10. So I want to move the decimal point between the 1 and the 4. So I've got 1.408. We know we have to put times 10 to the power of something. How many places has this jumped? Well, it was here. It's now moved 1, 2 places to the left. So times 10 to the power of 2. The most common misconception that we see with this is people think, well, there's 3 places after the decimal point, so it must be times 10 to the power of 3. But remember, that's showing you how many places the decimal jumped. So it's jumped from here to here. It's only moved 2 places. So it must be times 10 to the power of 2. Try some for yourself then, guys.